Hey guys, we are going to do another video on what a compound inequality is and just kind of practicing some of our skills, trying to increase that skill level. So today's essential question to write in your notebook is, what types of compound inequalities can I solve? And our topic is 2.5. We are still in chapter 2, section 5 of our book, assuming you're in the same book as we are in class. And we're just going to kind of dive right into compound inequalities today. Starting with a question, I want you to, you don't really have to write this part down, but I want you to kind of think about this a little bit. So none of you are probably driving yet, but eventually you will be driving. So let's talk dream cars here. Which car would you like? I'm going to show you some cars. Let's see, that one's looking pretty sportsy. Look at that beast of a car. Oh my gosh, look at that thing. That one's pretty sleek, pretty nice, really expensive. That thing is very expensive. That's an Escalade. That thing's huge too, beastly. And then you got this thing. I don't even know how that muffler on top thing works. So out of all those 5 cars, which car would you pick if you had your choice? I'm kind of curious. When we meet in small group, you can tell me. So we're going to talk about driving today. And of course, if you want one of those cars, you can't just drive until you get your driver's license. So maybe you don't know too much about what it takes to get a driver's license. Maybe you do. Maybe you have an older brother or sister who's done this before. But before you can drive, you have to be a student driver, and you have to take a course and a class to practice your driving skills. In Washington State, we have rules, we have regulations. You can't just get out on the road. So if you're curious, how do I get my driver's license? Here are the steps to getting your driver's license. First, you got to get what's called an instructional permit. It's a practice license that you have to use for at least 6 months. So you get that practice license, and then you go out and you do just that. You practice. You have to have 50 hours of driving practice with an adult in the car with you. So you have to kind of get your driving time in. Drive with your mom, drive with your dad, drive with your uncle, drive with grandma, and get your practice hours in. And then when you're done, or in the middle of that actually, you complete what's called a driver's training course. You take a class basically on how to drive cars. And in that course, you have to both drive and do book work where you learn the rules of the road. And you pass what's called a teen driving safety test. You have to take this like safety test. So yeah, there are some tests involved. Then here are some other things. You got to turn 16. You can't be below the age of 16. You can't have any traffic violations within the 6 months that you apply. So if you get pulled over and get a ticket or anything like that, you won't be able to get your license for at least 6 months. No alcohol, no drug, obviously, offenses. If any of that shows up on your record, you're not going to get a chance to get your driver's permit until at least 18. Or your license until at least 18. And then you have to pass what's the official driver's test at the Department of Licensing. So that is that final drive test that you probably have heard many people talk about. There's also a written test that you take that's all about the rules of the road and what rules do you have to follow and things like that. So you do all that work. You take your class, you get your 50 hours, you pass your driver's test, you pass your written test, and you're ready to get your license. But there's still more steps. Even after you pass everything, you have to bring your parent in. Your parent has to authorize it. You have to have a social security number to get proof of residency. You have to pass a vision test. You have to pay a licensing fee. Everything costs. And of course, take the photo for your card. And you do all that, and you've got your license, and you're ready to hit the road. And hopefully by that time, you know the rules of the road. So why am I telling you all this in this video? Well, because I am going to take driving and turn it into a compound inequality. You like that? Turning driving into a compound inequality. Okay, so here's a state law that you might not know. If you're driving on the freeway is kind of like the highway where you have lots of lanes going quickly, probably in 2 directions. And it has a really fast speed limit, but did you know there's also a speed minimum? There's a rule you cannot go too slow on those freeways because cars that go really slow can cause major accidents. Cars that are going fast can catch up behind them, not see that they're going so slow, and it's actually super dangerous. So we have a state law that says on our highway with 4 lanes, the minimum speed is 40 miles per hour and the speed limit is 65 miles per hour. What that means is if you're going below 40 miles per hour and you're driving really slow, you can actually get pulled over and get a ticket for driving slow. But of course, speed limit, we all know what a speed limit is. A speed limit is the maximum speed you're supposed to go. If you go over the speed limit, that's when people typically get tickets for speeding, which we all know about. Well, this is a compound inequality. This is the part where I'd say, hey, grab your pencil. We're going to write some stuff down. We're going to write down that our variable is our car's speed. So I'm going to let x be the car's speed. Let x equal your car's speed. What do we know about your car's speed? Well, better be greater than 40 miles per hour. It can be greater than or equal to 40 miles per hour, but don't go under. You'll get a ticket for going too slow. Be kind of a lame ticket to get. We also know that the speed limit is 65 miles per hour. So x is less than or equal to 65, meaning you got to drive somewhere between 40 and 65. And you can drive exactly the speed limit. You can go equal to 65, you can go equal to 40. People might honk at you and get mad at you for going slow, but you can. Or you can go anywhere in between there. So this is an and problem. This is totally an and problem. And how do I know that? Well, I'm going to put on a number line and it's going to make way more sense. So in your notes, draw a number line and we're going to add some numbers that fit the range of 40 to 65. So I'm thinking let's start at 40 and go by fives, like 45, 50, 55, 60, 65, 70, 75, 80. That's plenty of space. And if I'm going fast, just pause the video so you can do your number line. And then I'm going to circle my points that are important. So 40 and 65 is where I'm focusing. I'm going to start with the 40 first. X is greater than or equal to 40. So equal to and greater than. So shaded to the right, those are all the greater than values, and equal to means a solid point. X is also less than or equal to 65. Circle 65. Less than means to the left, and equal to means solid. So do you see that overlapping region? I used two colors. Maybe in your notebook you're using two colors also. But that red and that blue are overlapping. In that region, I'll circle it. That's our solution. That's where we actually want to do our dark shaded space. And what do we know? Well, our car speed can be anywhere in between there, between 40 and 65. You go above 65, you go below 40, you're looking at a potential ticket. It's a compound inequality. So next time you hop in the car with mom, dad, or whoever you're driving with, have a nice conversation about inequalities. See if your parents get it. All right, okay, so maybe you will, maybe you won't. We're going to try two more examples just to kind of practice in our notes. So I'm going to switch gears here. I'm going to switch screens so you can kind of follow along with me. Okay, so using your pencil, let's write down our next example here. Our next example is 3 plus 4r is less than 15, and negative 5 take away r is less than 4. Okay, so and tells me we're dealing with a compound inequality. Probably going to be one of these overlapping problems for sure. We're going to solve each of them separately to get our solutions first. So a little line down the inequality sign. Let's get r by itself. So kind of going through my steps here, I'm going to take the 3 away first from both sides. That'll get rid of my 3's. I'm still going to have 4r left over. So 4r is less than 15 take away 3, which would be 12. And then we're almost done. We just got to divide that 4 away. So I'll divide by 4 on both sides to get rid of the 4. And r is going to be less than 12 divided by 4, but 12 divided by 4 is 3. So there's our value. R is less than 3. Now if I really wanted to get technical here and like go for that level 4, I could be naming my steps as I go. Like when we subtracted the 3, we call that the subtraction property of not equality because it's not equal, it's inequality because it's not equal. Inequality. That's this step right here. Subtraction property of inequality. So if I had extra time or I'm on a test, I might go through and do all that. This step right here where we took the 4 and we divided it, that's the division property of inequality. So I'm going to write that down, division property of inequality. And this is your notes, so maybe you should write it in your notes. It's good practice. It might not be something you do on like every homework problem, but for your notebook, it'd be nice to write some of that down. Okay, so we've got our answer, r is less than 3. We're not totally done though. We got to go over here and solve also, so we have a little more work to do. On this side, I'm going to take this negative 5, and I'm going to add the 5 to the other side. We call that the addition property of inequality. It's still, when it moves, going to leave us with this minus r. Notice how that's still remaining. So we still have a negative r is less than 4 plus 5, which is 9. And then we really don't want negative r to be our answer. So there's kind of two ways you can do this. You could do the thing where you're like, okay, I'm just going to flip-flop everything. I don't want negative r to be actually negative. So I'm going to move it over here to make it a positive r. And that means I have to trade the 9 over and make it a negative 9. Opposite signs. So negative 9 is less than r. There's our solution. There's actually another way we can do this too. We could have divided by a negative 1. It would flip the symbol and it would end up giving us this exact same answer. It's just two different approaches. But now that we've got our two numbers, let's move to the next step here. And the next step is get this thing on a number line. So I'm going to sketch a number line using my graph paper. There we go. I know we've got 3 and negative 9. So when I go to start setting up my scale numbers, I want to make sure I fit those numbers. So I'm going to try to make this nice and neat. I hope I have enough room here. Let's see, if I started, let's say I put negative 9 way down here. This would be negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Sweet, I have enough room. Kind of eyeballing this. And then what I'm going to do is focus on those two numbers. So let's start with the r is less than 3. R is less than 3 means circle 3. It's less than, so we are talking this direction to the less than direction. And it's not equal to, so I'm going to leave it empty. And then on the other side, we have r is greater than negative 9. So I'm going to switch colors. Actually, I use the same color. R is greater than negative 9. So here's negative 9. Here is the greater than direction going to the right. No equal sign, so I'm going to leave it empty as well. So do you see how they're kind of pointing towards each other and we're going to have overlap? Our overlap solution is everything in the middle here. That is our solution, and I like to call this one, I've said this in class before, but I call it the sandwich problem, where the variable is sandwiched in the middle. It's in the middle of negative 9 and 3. So the final way to write my answer is to do this. R is between negative 9 and 3 on the number line. It is bigger than the negative 9 but smaller than the 3. Here is my final solution. Some people circle this as their answer and then they put the word and in the middle, and that's totally okay to do, but this is the same way as doing that, and it's kind of good practice. So I'd really, like on tests and quizzes and stuff, I'd really love to see you be able to do this. I think it goes really well. It complements your number line and your answer very well. All right, so there's our and problem, and if you kind of step back and look, looks pretty nice. I'd say it's a level 4. I think maybe I need to add my 2 properties here. So like addition property of inequality, I could add that on, but besides that, it's looking pretty good. We're going to try one more for this video, and we're going to switch gears and try an OR problem. So for your last example in your notebook, we're going to solve negative 7 minus 9x is greater than 56, or 2 minus 8x is less than or equal to 2. So we have 2 different problems. This time we're dealing with an OR situation, so it's going to be a little bit of a different number line. And I'm going to put my line down the symbol here, just like so. And we're going to solve for x on both sides. So let's cruise through this a little bit here. I'll start on this side. I'm going to add the 7 over to move it over. And I'm going to add the 7 here. When I do that, I still have that minus 9x. So I still have a negative 9x. And it is greater than 56 plus 7. So what would that be? Well, that would be 63. 63. Okay, so keep on going. We're going to divide by negative 9 on the left and on the right. So divide by both sides. That'll get rid of my 9s. It'll get rid of my negative. Just a little hint. Some of you guys are using the calculators from the classroom, and that's totally fine. But when you go to type in a problem like this, just be sure when you type in 63 divided by negative 9. So I'm going to type in my 63. Hopefully you guys can see it. I'm going to hit divide. My negative 9, the negative button is that little button right there. So be sure you're using the right negative button. Sometimes people have a hard time with that, but sometimes people try to use the subtract button, but you actually have to use this one for the negative. And then it should all work and not give you any kind of an error message, hopefully. So there's our solution, negative 7. We knew that in our head already, but just to kind of practice that calculator skill. And then, oh, what did we just do here? We just divided by -9. What happens when we divide by a negative? We gotta flip the sign. This is a flip the sign problem. So now it's x is less than -7. There's our solution. Cool, let's do the other side. Same kind of strategy. We are gonna take the 2 away on this side. Take the 2 away. Oh, here's something interesting. We're gonna take the 2 away and we're gonna get just a -8x. -8x is less than or equal to 2 take away 2, I guess we're going to end up with a 0. And a lot of people on tests will start saying, well, this looks like a no solution. But it really doesn't. The x's aren't gone. The x's are there. We can still solve. I'm going to divide by -8 on both sides to get rid of those 8's. That gets x alone. And 0 divided by a -8, 0 divided by anything, is still just 0. But we divided by a -8. Negative means flip the sign. So now x is greater than or equal to 0. There's our solution. Don't think that's a no solution or an all real numbers situation. It's okay to have 0 as your answer. No solution in all real numbers is only when the x's completely disappear and they're not even in the problem anymore. But x is still here. It didn't disappear. All right, so let's take this problem. I'm going to throw the word or in the middle. And let's get this on the number line so we can see what it looks like. So I'm going to grab my different color here to draw my number line. Try to make this nice and neat on my graph paper. I'm going to set up a scale that focuses on fitting in -7 and 0. So I'm going to make sure, like, let's say this is -9, -8. There's my -7. Here's my -6, -5, -4, -3, -2. -1, and then here's my 0. And I'll put 1, 2, 3 on here just for a few extra numbers. Making sure I get the right numbers on the number line. Okay, so let's graph it. So let's start with the x is less than -7. Less than -7 means here's -7. Less than means to left. We're talking this direction. These are the less than values. I'm going to draw a big arrow going to the left. I'm going to leave it empty because there's no equal sign, so empty hole on -7 shaded to the left. Then I'm going to do x is greater than or equal to 0. So here's 0. Greater than or equal to greater than means this direction to the bigger values. Again, I'm going to draw a big arrow to kind of emphasize that. And equal to means I get to make it solid. So here's my OR graph. Notice it's a little different than an AND problem. It's shooting off into two directions, one to the left, one to the right. And my number line, my values for x are basically everything but this small section. So x could be anything greater than 0, anything less than -7. That's a lot of choices for x, a lot of possible values. And then I'm done. All right, and there's our work. It looks pretty good, nice, neat, and organized. So continue to focus on being like very careful with showing your steps, organizing your work so people can read it. You really want it to be like a standalone thing. Like this paper, I want to be able to walk away from my video and anybody can watch this and understand what I'm doing. It doesn't have to be someone that knows me. So it's really important that your work does the same thing. It stands alone. Anybody should be able to pick up your paper, look at it, and understand what you were thinking and how you solved that problem. So algebra is really crucial for organization. I'm going to say that all year long with you guys, but just super important. And some of you guys are naturally kind of tend to want to organize and it's like kind of how you work and operate, but for others that's a struggle. And if you're like one of those people that's like, I never organize my work, that's not how I think, then you have to push yourself and you have to practice that skill a little bit more. And that's cool. That's okay. All right, guys, thanks for watching. I will see you in the next video. Bye.